The installation method described using Unistrut and swivel connectors is permissible according to the National Electrical Code, or NEC. To install using the Unistrut wireway method, firstly secure the Unistrut channel to the existing 0.75-inch conduit using swivel connectors. Ensure the wireway is positioned parallel to the conduit and extends the full length of the proposed fixtures. Secondly, attach swivel connectors to the Unistrut channel in the desired locations for the fixtures. These connectors should provide the necessary support and adjustability for the fixtures. Thirdly, hang the 4-foot T5 fluorescent fixtures from the swivel connectors. Fourthly, run the electrical wiring from the branch circuit through the Unistrut wireway and connect it to the fixtures. Ensure the wiring is properly secured and protected from damage. Fifthly, complete the installation by securing the fixtures to the swivel connectors and tightening all connections. Test the fixtures to ensure they are operating correctly. An alternative installation method is to use fixture whips. Firstly, purchase fixture whips that consist of a flexible conduit with pre-wired connectors on both ends. One end of the whip will connect to the branch circuit and the other end will connect to the fixture. Secondly, hang the fixtures from the existing 0.75-inch conduit using pipe straps or other suitable support. Thirdly, route the fixture whips from the branch circuit to the fixtures and secure them to the conduit. Fourthly, connect the fixture whips to the fixtures and to the branch circuit. Fifthly, complete the installation by tightening all connections and testing the fixtures. Both the Unistrut wireway and fixture whip methods are permissible for this installation. The choice between the two depends on factors such as the desired appearance, cost, and ease of installation. The Unistrut wireway provides a more enclosed and professional-looking installation, while the fixture whips offer a simpler and more cost-effective option. When running the wiring, consult the NEC for proper wire sizing based on the amperage draw of the new fixtures. The NEC dictates requirements for conductor ampacity, overcurrent protection, and grounding. It is important to consult the most recent edition of the NEC and to comply with all applicable local codes and regulations. Pay particular attention to Article 300.11 of the NEC, which covers securing and supporting wiring methods. This section requires that wiring be securely fastened in place and supported at appropriate intervals. Also relevant is Article 314, which addresses junction boxes, pull boxes, and handhole enclosures. These boxes may be necessary for making splices and connections within the Unistrut wireway or when using fixture whips. Grounding is crucial for electrical safety. Ensure that the fixtures are properly grounded according to Article 250 of the NEC. This typically involves connecting a grounding conductor from the fixture to the equipment grounding system. Overcurrent protection, such as circuit breakers or fuses, must be properly sized to protect the branch circuit wiring and the fixtures themselves. Refer to Article 240 of the NEC for guidance on overcurrent protection requirements. When selecting materials, choose electrical components that are listed and labeled by a recognized testing laboratory such as UL or ETL. This ensures that the products have been tested and meet safety standards. For the Unistrut wireway, consider using a metallic wireway for added protection and durability. Ensure that the swivel connectors are appropriately rated for the weight of the fixtures and that they provide a secure and reliable connection. When using fixture whips, select whips that are of sufficient length to allow for easy connection and maintenance. The flexible conduit should be liquid tight to protect the wiring from moisture and corrosion. Regarding the existing 0.75-inch conduit, inspect it to ensure that it is in good condition and capable of supporting the additional weight of the new fixtures and wireway. If the conduit is damaged or corroded, it should be replaced before proceeding with the installation. Verify that the existing branch circuit has sufficient capacity to handle the additional load of the new fixtures. Calculate the total amperage draw of the fixtures and compare it to the ampacity of the circuit breaker or fuse protecting the circuit. If the existing circuit is not adequate, a new circuit may need to be installed. In addition to the NEC, local codes and regulations may impose additional requirements for electrical installations. Check with the local electrical inspector to ensure that the installation complies with all applicable rules. Proper planning is essential for successful electrical installation. Before starting the work, develop a detailed plan that includes the location of the fixtures, the wiring routing, and the materials needed. This will help to ensure that the installation is done safely and efficiently. Safety is paramount when working with electricity. Always energize the circuit before starting any work. Use appropriate personal protective equipment, such as safety glasses and insulated gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the job. When making connections, use appropriate connectors and ensure that they are properly tightened. Loose connections can cause overheating and electrical hazards. After completing the installation, thoroughly test the fixtures to ensure that they are operating correctly and that there are no electrical problems. Use a multimeter to check for proper voltage and current. Inspect the wiring for any signs of damage or overheating. Document the installation with photos and drawings. This will be helpful for future maintenance and troubleshooting. Keep a copy of the NEC and any applicable local codes on site for reference. Regularly inspect the electrical system to identify and correct any potential problems before they become serious hazards. When working at heights, use appropriate ladders or scaffolding. Ensure that the equipment is stable and that you are following proper safety procedures. Be aware of your surroundings and avoid contact with any overhead obstructions or power lines. When drilling holes or cutting conduit, wear safety glasses to protect your eyes from flying debris. Use appropriate tools and techniques to avoid damaging the existing electrical system. If you encounter any unexpected problems or challenges during the installation, consult with a qualified electrician for assistance. Do not attempt to make repairs or modifications that you are not qualified to do. Remember that electrical work can be dangerous if not done properly. Take your time, follow all safety precautions, and consult with a qualified electrician if you have any questions or concerns. Consider using energy-efficient T5 fluorescent lamps to reduce energy consumption and lower operating costs. Check with the local utility company for any available rebates or incentives for energy-efficient lighting upgrades. Properly dispose of any old lamps or electrical components according to local regulations. Fluorescent lamps contain mercury and should not be thrown in the trash. Regularly clean the fixtures to maintain optimal light output and prevent dust buildup. Use a soft cloth and a mild detergent. Be sure to energize the circuit before cleaning the fixtures. If the fixtures are installed in a damp or wet location, use fixtures that are rated for wet locations. These fixtures are designed to withstand moisture and corrosion. Consider using occupancy sensors to automatically turn the lights on and off based on occupancy. This can save energy and extend the life of the lamps. When selecting a location for the fixtures, consider the lighting requirements of the skating rink. Position the fixtures to provide adequate illumination for skating and to minimize glare. Pay attention to the color temperature of the lamps. A cooler color temperature, such as 4000 Kelvin, provides a brighter and more energetic light, while a warmer color temperature, such as 3000 Kelvin, provides a more comfortable and inviting light. Consider using dimming ballasts to allow for adjustable light levels. This can be useful for creating different moods or for saving energy when full illumination is not needed. Ensure that the fixtures are properly aimed to avoid light trespass onto adjacent properties. Use shields or reflectors to direct the light downward and prevent it from shining into windows or causing glare. Consider the aesthetic appearance of the fixtures. Choose fixtures that are compatible with the overall design of the skating rink. Consult with an architect or lighting designer to ensure that the lighting installation meets all applicable codes and standards. Document all changes made to the electrical system on the electrical drawings. This will help to ensure that the drawings are accurate and up to date. Use a permanent marker to label all circuits and equipment. This will make it easier to identify and troubleshoot problems in the future. Keep a record of all maintenance and repairs performed on the electrical system. This will help to track the performance of the system and to identify any recurring problems. Regularly inspect the electrical system for signs of wear and tear. Replace any worn or damaged components before they fail. Consider using a surge protector to protect the electrical system from voltage spikes. This can help to prevent damage to sensitive electronic equipment. If you are planning to make any significant changes to the electrical system, consult with a qualified electrical engineer. They can provide expert advice and ensure that the changes are made safely and in compliance with all applicable codes and standards. When working with electricity, always be aware of the potential hazards and take appropriate precautions to protect yourself and others. Electricity can be dangerous if not handled properly. Consider the ambient temperature of the skating rink environment. If the rink is cold, use fixtures and lamps that are designed to operate in cold temperatures. Some lamps may not start properly or may have reduced light output in cold environments. When selecting fixtures, consider the ease of maintenance. Choose fixtures that are easy to clean and that have readily available replacement parts. Consider the life cycle cost of the fixtures. While some fixtures may have a lower initial cost, they may have higher operating and maintenance costs over the long term. Evaluate the total cost of ownership before making a decision. Consult with a lighting supplier to discuss your specific needs and requirements. They can help you select the best fixtures and lamps for your application. Remember to obtain all necessary permits before starting any electrical work. The local building department can provide information on permitting requirements. Be sure to follow all instructions provided by the fixture manufacturer. This will help to ensure that the fixtures are installed correctly and that they operate safely and efficiently. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician. They can provide expert guidance and ensure that the work is done properly. Finally, always remember that safety is the top priority when working with electricity. Take your time, follow all safety precautions, and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can ensure a safe and successful installation of new fluorescent fixtures over a skating rink. Always prioritize safety, adhere to the NEC and local codes, and consult with qualified professionals when needed. Consider the long-term performance and maintenance aspects of the chosen lighting system. The lighting in a skating rink has a direct impact on the skaters and the spectators. Poor lighting can cause accidents and eye strain. Prioritizing the correct lighting can enhance the experience for the skaters and spectators alike. Make sure that your chosen lighting complies with all the standards and regulations set forth by any skating or sports organizations. This can include lux levels, flicker percentages, and color rendering index. Before starting the project, carefully assess the existing electrical infrastructure. Determine the capacity of the existing electrical panel and wiring. If the existing infrastructure is not sufficient, it may be necessary to upgrade the panel and wiring. If the existing infrastructure is not adequate, it is important to seek advice from a qualified electrician or electrical engineer. When selecting lighting fixtures, it is important to consider the environmental conditions. Skating rinks can be cold and damp, so it is important to select lighting fixtures that are designed to withstand these conditions. Select lighting fixtures that are rated for wet locations or cold temperatures. If the skating rink is used for other events such as concerts or shows, it may be necessary to install additional lighting. This could include stage lighting, spotlights, and colored lighting. When installing additional lighting, it is important to ensure that it is compatible with the existing lighting system and that it does not overload the electrical system. The lighting in a skating rink should be designed to minimize glare. Glare can be a safety hazard, as it can make it difficult for skaters to see. To minimize glare, use lighting fixtures that have diffusers or reflectors. In addition to providing adequate lighting, the lighting system should also be energy efficient. Energy efficient lighting can help to reduce the operating costs of the skating rink. To improve energy efficiency, use LED lighting fixtures, install occupancy sensors, and dim the lights when they are not needed. Always check local codes and regulations.